Welcome, everyone. I'm Jim Irwin, Chair of the Riding Mountain Biosphere Reserve, and this is our 10th Lake Stewardship Workshop. I'll be hosting tonight's workshop, and Dennis Hodgson and Daryl Kynes will be assisting. To begin, I would like to acknowledge that the Riding Mountain Biosphere Reserve is in Treaty 2 and 4 territories of the Anishinaabe people and say that we respect and share their all-important teachings that water is a sacred gift essential for all life. Since 1986, the Riding Mountain Biosphere Reserve has been bringing people together to share their knowledge for the well-being of our communities. In this respect, we are honored to have Lisette Ross share her water knowledge with us tonight. Lisette has amazing extensive experience with water studies and projects. She has a master's of science in agriculture, specializing in prairie wetland soils and hydrological modeling. She spent the last 35 years researching Canadian wetlands with a focus on biodiversity, water quality, and the influence of surface and subsurface hydrology on the development and establishment of wetland vegetation, wildlife communities, and watershed water quality. She's authored 7 book chapters on wetland ecology, watershed health, and wetland construction. Additionally, she authored a special publication for the Walkerton Commission on the effectiveness of wetland and upland habitat to improve water quality. Along with colleagues from Environment Canada, she also co-authored the recommended national guidelines for assessing the functional status of wetlands in Canada. Lisette currently leads the wetland team of the Native Plant Solutions, NPS, which is the consulting arm of Ducks Unlimited Canada. She has played an integral role in establishing NPS's wetland design and construction standards. During her time with NPS, she has designed and built more than 100 naturalized stormwater facilities in Western Canada that help manage and improve the quality of surface water runoff. Her team has designed and commissioned large wetlands for the treatment of municipal wastewater in Manitoba communities, and they have also explored the application of floating vegetated islands for water quality improvement. Lisette's presentation tonight is entitled Innovative Tools for Source Water Improvement and Protection of Our Prairie Landscapes and Lakes. Lisette?
Thanks, Jim, for that really nice introduction. Well, thanks again for having me this evening. It's a real pleasure for me to present to the folks online this evening. I have enjoyed participating and hearing the presentations over the last number of weeks within this group, and I look forward to sharing some of my experience here with you this evening as well. When Jim says I've been around for 35 years, I want to say I started when I was 10 years old. But that's not the truth. Been around for a long time, and it's been a really interesting process of kind of watching the implementation of green infrastructure and just how our knowledge has transformed over the years to where we are today. And so I want to just share a little bit of that background information with you as we start this presentation this evening, and then share with you some real world application of some green infrastructure that we have installed within our group or investigated within our group at Native Plant Solutions. As Jim mentioned, Native Plant Solutions is the consulting arm of Ducks Unlimited. I was with Ducks Unlimited's research team for about 20 years before I made the leap to Native Plant Solutions. And we take our research and our knowledge and understanding of these natural systems and apply them in a real world way within our Native Plant Solutions group. One of the things I think that's just become evident as I work right across Canada with different municipalities different communities, different towns, conservation groups, watershed groups, is that there is no doubt that there's an increasing demand for cleaner water and better water management across many of the prairie provinces. I would say in every single one of the provinces, we have that as an issue. And I would also say that we have to be kind to ourselves in this process, because it has taken time to get where we are today. Initially when we were starting to settle the prairies, we kind of swung between looking for options for drought proofing the prairies because of decades where we had little to no water to work with, to finding ways of flood proofing the prairies as well when we went through decades of extreme water events. And at the time, we sort of did the best we could. But I would say that we've landed in a place now over the last few decades where we've learned a lot more. And I think that we can be implementing better practices across our landscape as a result. My first experience of kind of understanding the relationship between land use and water health was when I sort of first started my career after university, working at the Delta Marsh in Manitoba. As many of you probably know, it's a large inland coastal marsh that borders the south end of Lake Manitoba. It's about 17,000 hectares in size. It's a phenomenal marsh that we have here in the province. It was formed probably around 4,500 years ago when the Assiniboine River actually connected to Lake Manitoba at that time. And we had sediment deposits along that southern shore that led to the development of this marsh right along the south end of the basin. Because the marsh has been there forever, there's been a lot of research that has occurred on the Delta Marsh since the 1930s. Up until the present day, there is still a research team out at that facility at the Delta Waterfowl and Wetlands Research Station. But one of the things with having people there for a long period of time was through the 50s in the province, we experienced a tremendous amount of flood issues, especially around the Lake Manitoba Basin. And a lot of the marginal lands that were being used at that time around the basin were being impacted by these flooding events. And so the strategy at that time was, could we install a dam that would help us control the water levels of Lake Manitoba and in turn provide us with better access to those shoreline habitats? So in 1961, the Fairford Dam was constructed along the northern end of Lake Manitoba. And as a result, they were able to actually stabilize water levels and control lake levels much better after that. And initially, really what happened was, if you look at this graph from the 1920s to the 1960s, when the Fairford Dam was installed, the lake itself would go through these large, sort of almost decadal fluctuations in water levels, ranging about 10 feet in all between its high and its lows. But after the Fairford Dam was installed, what happened was they restricted the flooding scenario of Lake Manitoba into about a 30 centimeter range from that point forward. So it would never go up or down outside of really that 30 centimeter range. And because there had been researchers at the Delta Station since the 30s, they started to see, not very long after the installation of the Fairford Dam, changes in the Delta Marsh itself. And what was happening, and we were just beginning to sort of understand what drives the productivity of these shoreline habitats, was that when we took away the highs and the lows of Lake Manitoba, we also took away the highs and the lows of the Delta Marsh. And that had a very detrimental effect on the productivity of the marsh overall. Without going through these dry periods and wet periods to kind of reinvigorate the plant communities within this Delta Marsh, we started to see a lot of the plant communities disappear altogether, and many of them for the next number of decades, and many of them have never returned since then. Simpson Bay is a famous bay in the Delta Marsh, and looking at the effects not long after the Fairford Dam was installed to about 25 years later, some of those islands and vegetative communities were completely wiped out through the stabilization of the lake, which in turn stabilized the marsh. And so this really important relationship between the two water bodies was affected by this action. And the water quality treatment capacity of the wetland was affected as well. By losing vegetation within the marsh itself, you were losing that water quality treatment capacity that you would see on these coastal wetlands, but also think in terms of shoreline habitats around lakes where we have these vegetation communities. The Lake Winnipeg scenario is not that much different. When you look at the Netley-Lebo Marsh on the south end of the Lake Winnipeg Basin, it's about 26,000 hectares in size, so substantially bigger than the Delta Marsh, one of the largest inland coastal wetlands that we have in Canada. Again, this wetland intricately linked to Lake Winnipeg. A lot of the water flows through that south end of the lake, and as it flows through the wetland would be improved in terms of water quality before it entered the lake itself. Settlement since the 20s have affected the amount of water that's going through this system. So we've increased water levels that way. And then other activities such as hydroelectric have, similar to Lake Manitoba, led to more of the stabilization of the lake, which in turn has been a detriment to the Netley-Lebo Marsh. And again, it took till around the 1970s for us to start to see the implications of managing water on our landscapes and the associated habitats. And from 1979 to 2001, the open water marsh areas increased from about 35% to 51%. Flood-dependent species, so species like soft-stem bulrush and hard-stem bulrush, which are a little bit more linked to flood up and flood down events, decreased tenfold. And it's pretty substantial when you think of going from 3,200 hectares to about 317 hectares. You've lost a lot of treatment capacity in that kind of loss. So we've seen some of these relationships happen on some of our bigger lake systems. And this really sort of started, I think in the 60s and through to the 90s, where combined with understanding how these systems were changing, we were still just trying to gain a fundamental understanding of what drove the productivity of some of our natural habitats on our prairie landscape and what role they played in sort of that whole watershed, water quality result. And it really wasn't, when I think back, it's part of this presentation, I'm thinking back over the things that have happened since I started at the Delta Marsh in '85. It wasn't until about 1997, 1998, where we held a special session and did a special publication through Great Plains Research that looked beyond just understanding the ecology of wetland habitat and started to recognize that wetlands could actually play a big role in improving water quality, in improving and reducing sedimentation rates, in improving carbon sequestration and thereby offsetting greenhouse gas emissions. It really took almost till the late 90s. So it's only been about 23 years where we've kind of said, there's a role that these green strategies can play on our landscape. And now that we're kind of understanding that, can we start to apply that and study that along the way to see how well they're doing? So I often say we have to be kind of kind to ourselves. Sometimes we're impatient and we think we should be farther ahead than we are, but there's reasons why we're not. And, I would say lucky, unlucky. And so unlucky that we've seen some of the effects to some of our larger lakes in Manitoba. But when I look across Canada, I think because we have Lake Manitoba, we have Lake Winnipeg, and we've seen these very obvious impacts to the way that we've moved water across our landscape in these lakes. It has caused us and called us into action in a way that I haven't seen in some of the other provinces yet. And so in that way, I would say that we've been lucky because it's created a movement within Manitoba to really understand ways that we can just improve water quality and water health across our province. And I would say that it's interesting because it's happening in every city too. Like this upper shot is a shot of a vegetation harvester that the city uses in some of its conventional stormwater ponds, as one of the only strategies for managing sort of unsightly vegetation blooms within some of the urban areas within the city. And this is an image of the duck pond at Assiniboine Park. And I knew when they were building this pond initially that you could almost predict when they were building it that they were going to have water quality problems. And within 2 years of actually building it, they did. And this is a shot of the water quality. Too much hard infrastructure, trying to maintain and manage water within a footprint, trying to control it, and not thinking about what the water itself needs in order to maintain its health. So, one of the things when I've been, I've probably been sort of sharing this message for the last 10 years as I go from, municipality to different jurisdictions is that, our general practice has been to manage water off our landscapes as fast as possible. And I understand the reasons for that. But, due to the water quality issues that we are now seeing more widespread, we should really consider, and I think about this, improve and then move. So are there ways that we can actually improve our water upstream of our lower downstream water bodies and then have it move towards those downstream areas after that? And this is a slide kind of depicting optimally what we would want is, to maintain the wetlands, as many wetlands as we can on our landscapes, if that's possible, and to keep them in good health, to maintain good riparian areas along our waterways, and to think about how we manage those edge areas in terms of erosion and so on. Unfortunately, we, in many areas, we've kind of moved to that kind of approach where moving water off as fast as possible into our connecting waterways has really been the norm. And we've had some consequences as a result of that. And in 2005, I wrote an article for our national magazine, and I pulled it out when I was preparing for this presentation. The article was related to the consequences of water quality and human health. And we don't often think about really the costs associated with when you swim in a water body that, unbeknownst to you, has pathogens in it or E. coli issues in it. There's a good chance that you will get sick and that there's a cost associated with that. But one of the things that I said within that article is, to want to make water to do what we think it should is understandable, but is it always right? So over the last 25 years, there has been this emerging body of literature supporting the capacity of these naturalized habitats for removing pollutants. And there's been more and more research over time that shows that the waters leaving water bodies and riparian areas that have these naturalized elements are cleaner than the waters entering then into them. And I would say that there's defining moments in where we kind of shift our direction. And I would say that one of the defining moments in shifting our direction and our perspective on land management was when we had Walkerton and the E. coli outbreak in the spring of 2000. And we had many people get sick and some people die from that event. And I think it was one of the first times in Canada where we sort of really realized that there can be consequences to how we manage water across our landscapes. And not long after that was the cryptosporidium outbreak in North Battleford in Saskatchewan in the spring of 2001. And I remember it was the first time I was traveling across the prairies, and you would stay in hotels depending on where you landed that day after doing your field work. And it was the first time where I would see motels and hotels actually have as part of their advertisement on their billboard, clean drinking water is available here. And it was kind of shocking because in Canada, we've always sort of thought that, we've done a really good job in that respect. And these events really kind of opened our eyes. And it was after, I think Walkerton, where we sort of said, we really think that there's some value in what we would call natural capital. And do we know enough, and should we know more? And so as part of the Walkerton Commission, we looked at the ability for different land practices to improve water as it moved across it, and looked at a number of scientific publications, not only from Canada, but also from the United States, and particularly the Great Plains region of the United States, to see what kind of capacity we had by managing our land differently. And from that initial investigation, what we understood was that if you combine good upland management of particularly, I would say, marginal landscapes within your watershed, and you combine that with healthy riparian areas along your waterways, and then also to that, you add wetland habitat that can kind of hold and release water and improve it before it does so, that if you combine those different strategies with one another, your capacity to improve and remove nitrogen, phosphorus, sediments, pesticides, pathogens is incredible. And if you look just specifically at the ability to improve and remove phosphorus using these different kind of green strategies on your landscape before it gets to the end basin, the opportunities here to kind of, I would say, look up and look out away from, your basin allows you to have some tremendous opportunities for water quality improvement. This is busy, there's no doubt about it, but I think what it indicates is these are the ways that aquatic plants, wetland habitat, those wet riparian areas actually improve water quality through some of both their chemical and their biological processes. And think about this, whether these are plants that are along the shorelines of your lake, whether they're plants that are in wetlands holding water before it gets to the lake, riparian areas, bordering streams and other kinds of wet habitats, and even in bioswales and ditches. I look at, we did a shoreline inventory of Lake Winnipeg in 2013, and we inventoried the entire South Basin. And one of the things that we did is we looked at how many ditches and pipes were coming into the South Basin that were having little to no treatment before they actually entered the lake itself. And it was quite shocking how many direct pipes we counted as we did that South Basin area. And I think to myself, even improvements to ditch networks as water moves through our communities before it gets to those endpoints has got a lot of capacity for improvement in those locations. So when you look at wetland habitat, there's a lot of things working in conjunction with one another. You've got good algal communities, you've got microbes, you've got the plants themselves, all of those communities very hungry for nutrients for their survival. We have the sediments storing a tremendous amount of nutrients within the sediments themselves. They tend to be one of the biggest sinks within these systems. We have breakdown of toxic elements, microbes and algae work together to help against some of the pathogens in these systems. And then things, extra benefits like carbon sequestration in the soils that help to offset some of the greenhouse gases that we emit on a daily basis. And the upland areas are the same. When I think about the upper right slide is a bioswale that we did along the Canadian Mennonite University Library in 2015, I believe. There's even by putting in that ditch network that has maybe native grasses or tame grasses in it that improve infiltration rates and improve uptake rates. The treatment capacity, just moving water through those components in our landscape, is quite great. So just to kind of finish off on some examples of some green infrastructure and some of the pros and cons from my own experiences in their application on the land, I want to just talk a little bit about bioswales or those ditch networks, floating aquatics, floating bioplatforms, treatment wetlands, which we've built some of here in Manitoba and in British Columbia, and then naturalized stormwater ponds. So when I think of bioswales and our ability to kind of improve some of the way that water runs through our ditch networks, it fits well within many landscapes. It not only helps with nutrient and carbon retention, but I think of the big storm that we had up around the Riding Mountain area in late June, early July of last year, and it was a tremendous storm. And we had a lot of runoff from the land at an unusual time of the year, carrying probably many constituents with it. If you think that you can have in place some of these ditch networks that have tame or native grasses and the infiltration rate is improved as a result, that you also have good flood moderation, having those in place. Biodiversity, it's a hot topic these days, and by having these on the landscape, we can improve that as well. If done right, low maintenance as well. Some of the challenges that you have with some of these is they can be a source of phosphorus at certain times of the year. So their best performance is going to be in the summertime when you've got better infiltration into the soil. In the spring, where you may have an ice seal in your soil and the water is running off through these habitats, perhaps carrying some of the phosphorus, not only from the soil, but also from the plants, the kind of the dry, dead matter in the spring, they can actually be for a short period of time a source of phosphorus to your downstream areas. They take time to establish. And I think because they are both dry and wet environments, perhaps at different times of the year, it's really important that you think about picking the right species that can take advantage of either one of those conditions depending on the year. Floating aquatics, I think of things like using sago pondweed, using lemna, which are small floating plants within some of our aquatic systems to uptake and help remove nutrients. I would say a couple of things from my own personal experience is that there is the potential for you to do that. It's not easy. It's hard enough to establish aquatic vegetation and to get it right in the way that Mother Nature gets it right in aquatic habitats. And lemna and sago, they're no different. Their establishment and the ability to kind of predict their performance is unpredictable. They are going to die at a certain period of time, and if you don't remove them, the nutrients that they hold will go back into the system. And so you're going to have to harvest them continuously, and you're going to have to know how to seed the site in order to make them come back. One of the things when you have these thick mats of vegetation on surfaces is you affect the water column beneath it. And so you can change the temperature of the water column. You change, of course, the light that's coming in there. You can affect the aquatic invertebrate community underneath there. And so you need to know that there could be consequences. What we say is you might improve one function within the system, but it might be to the detriment of other functions within the system. Floating bioplatforms has been quite popular, and we started studying them in around 2012. It was a cooperative project with folks at the University of Manitoba, IASD, ourselves, researchers at Ducks Unlimited. Fort White was part of that process as well. And I would say that there's potential for them to be used in certain locations, but there's cautions that I would put to floating bioplatforms. One is that it can only hold so much nutrients. You remember that the soil is actually one of your big nutrient sinks within these systems for holding things like phosphorus and not releasing it back into the system. You lose that when you've got a floating bioplatform because your substrate and the roots within them is actually very shallow. And so the only way to kind of keep them for continuing to remove nutrients is that you have to harvest them. And that's a continual job. And so I would say that's not easy to do over water. How do you harvest them? You've got to remove that material. How do you do it in a way that you're actually not harming the plants over the long term? They're higher maintenance, and we found some challenges with them. So they overwinter quite well. But one of the things, and if you think that cattail is probably your best workhorse for nutrient uptake and improving water quality, one of the things that we found in Manitoba is that there's a few species of moths that love to bore into the stem of cattail that are on these sort of floating platforms. And by doing that, they harm the plant to the point where they can kill the plant, and you can lose your entire community on these platforms. The other thing that we learned is that they can be great loafing areas for wildlife, which is it's wonderful, but it's really not the intent. I mean, the community of ducks on this is tremendous, but the damage that they've done to the platforms is substantial. The other thing we found is that we wanted to look at how many platforms might you need in order to really substantially improve water quality within a basin. So at Fort White in Winnipeg, they have a fairly large lake called Cargill Lake, and we executed a number of platforms on the lake, and we ran analysis on them to say how much cover would we need to actually make a dent in the phosphorus levels within Cargill Lake. And we would need, through our calculations, about 29% of the lake covered by floating bioplatforms to reduce about 10% of the phosphorus in that lake on an annual basis. So when you think of the amount of infrastructure and the maintenance of something like that to get that kind of return, I think you have to really sort of stop and think before you execute on something like that. The other thing that we wanted to understand was how often could you harvest the plants and not harm them? If you think about it, it's important in the fall for the plants to take those above ground nutrients, put them in the below ground root reserves that they can then draw upon the next spring for their new growth. And when you remove that upper vegetation, you remove the ability for them to translocate those nutrients for the winter period. And so we looked at harvesting. This is one where we didn't harvest the upland plant to remove the nutrients on the platforms. And this one with the open circles we did. And even, after about 40 days, the plant never grew back. And so the plants that are entering into the winter system on a floating bioplatform in this condition are likely going to be challenged for survival to the next spring. Two types of wetlands. We have experience in surface wetlands, subsurface wetlands. I know they have been tried in certain locations within Manitoba. They tend to need a high surface area for treatment. So that can be a benefit of them. They don't require harvesting. That's a benefit. They have long-term storage. That's a benefit. Depending on the substrate material you use. And so you've really got kind of a dry situation here where water is coming in through a porous substrate and being improved as it flows through the root system of the plants. You can have clogging in the treatment system, which ultimately can affect your treatment capacity within it. One of the things I know is that plant establishment within these kinds of systems can be challenging and difficult. And because of the clogging and sedimentation, depending on the substrate that you choose to put down in here, you can have sort of ongoing maintenance issues. When it comes to surface flow wetlands for treatment, what you introduce is all the features here for improving water quality as it moves through the system. They're available and suitable for small and large communities. Once they're established, the maintenance costs on them are almost negligible. You do not need to harvest the vegetation within them to remove the nutrients. They are designed for long-term storage and to be able to function over many, many decades. The other thing that I like about surface water treatment wetlands is that you also create an opportunity to contribute to biodiversity, which the subsurface ones don't. And so within the treatment wetlands that we've done in communities like St. Pierre, La Broquerie, St. Anne's is building one. We have found turtles in them. We have found muskrats in them. We have found ducks in them, and the water quality in them is really good. So having these extra critters using these systems is just a benefit. We've used them for end-of-life scenarios. So this shows the old primary cell in Niverville, Manitoba, their old lagoon system, which had to be taken off license as they built their new system. And because of that, they had to remediate it. They wanted to look at different ways of remediating it instead of the usual process where you actually remove the biosolid waste and spread it on agricultural fields. They wanted to look at doing it in situ. And so we worked with the community to turn their primary cell back into an actual wetland cell where we have the plants actually growing on recontoured biosolid material, and not only use phytoremediation or plant remediation to get those soils back into a state that's both safe for the environment and safe for human health, but also to create a habitat that looks like it's almost always been there. That ultimately is the goal. And so they've incorporated this now into part of their amenity in their sort of park area, which is central to their community. And we are going to the regulators within the next month to request removal from license. So after this point, Niverville can build pathways around the site, can have interpretation around the site, and can use it for their community without any kind of reservations about it once being their wastewater treatment lagoon. This is an example of the treatment wetland that we built for the community of St. Pierre. It's a population of about 25 to 3,000 folks. There are now pretty stringent phosphorus targets that all these wastewater facilities need to meet before they can release to the environment. And for some of these communities, their ability to put in high-end infrastructure or to use chemical treatment to remove that phosphorus before wastewater release is just not doable. And so we've brought this option to Manitoba and beyond of using treatment wetlands to improve your wastewater before it's released to the environment. And this kind of shows, just as we're commissioning the treatment wetland, there's a primary and secondary lagoon cell that feeds into this treatment wetland to established later on that same summer with cattail plants. These are very functional. They're not designed to be pretty, but they're very functional in the treatment capacity that they provide. And I would say that I think one of the things I like about this is this shows you sort of the potential of using green infrastructure for improving water quality before it reaches endpoints. So this is the level of phosphorus, total phosphorus that we've seen in the secondary lagoon before it actually entered into the St. Pierre treatment wetland. So it was above 1.5 milligrams per liter. And when we looked at the treatment as it was leaving the St. Pierre lagoon, it was in and about 0.07. And the provincial guideline is to meet 1 before release. And it releases into the Rat River. And we thought, let's look at the Rat River just to see the water quality within the Rat River. And the St. Pierre treatment wetland was out competing its water quality compared to the river itself. So we were putting better water into the river than what was in the river. And this slide on the right kind of shows you, this is the secondary wastewater treatment, and this is the water quality and color that's leaving the wetland after it's been in that wetland for about 14 days. Lastly, naturalized stormwater ponds. You know, I say that you can do really good things in very small locations. And it doesn't have to be a pond this size. But the intent when these were built in the 1970s and 80s was that we would store water and we would kind of promote to people living around them that they're living around a pristine lake. And unfortunately, without having sort of that naturalized component in these systems, eventually you reach a tipping point in these systems where there's nowhere for the phosphorus to go. And if there's nowhere for the phosphorus to go, it either has to go to submersed vegetation, some kind of algae, and hopefully not toxic blue-green algae. And so really Winnipeg and Manitoba has been a leader in introducing these naturalized systems into smaller environments. This is an example of a small constructed wetland that we built, stormwater pond, that all it does is receive parking lot runoff before it enters the main stormwater network. And so just thinking about including these, as especially as many of our smaller communities are really expanding at a rate that's hard to keep up with, these, I think, provide options for improving water before we move it downstream. So I'll just end with a few thoughts. There's many options that exist for improving surface water quality using green strategies, and some of which that I've shared with you here today. I really think that in evaluating your watershed and prioritizing improvements will help result in the greatest returns on effort. There are often a lot of things that you can do, and picking and choosing and prioritizing them will ensure that you get a good bang for your buck. If a water quality fix is quick and easy, and I see a lot of this across jurisdictions that I go, and we are in some of those helping to fix the quick and easy fixes. If the fix is quick and easy, I would say first and foremost, question its longevity for permanent and lasting treatment. Is it something that you're going to have to continue spending money on? And is it something that you have to continue managing? Try to stay away from treatment options or landscapes that need to be highly managed. And the reason I say that, and it comes from experience, even being in Ducks Unlimited for the last number of decades. We built big projects with big infrastructure, and we thought we could manage it all really well. And like a lot of jurisdictions and other organizations, we find that if you don't put the time and effort in, and to ensure that you've got that time and effort in over the long period or the long haul, there'll be consequences to that system over time. So if it needs to be highly managed, you need to ask, will those involved in the project now still be around in the future to put in the effort required to ensure that management continues? While some green treatment options require some work and planning on the front end, it's not always easy to get them established. You need some know-how when it comes to plants. You need to stick with it. So on some of the sites, many of our sites, when we build them, we design them and we commission them, we're on for 5 years before we hand them off, because especially for some of the native grass uplands, it takes at least 2 years of growth before you actually see good growth above ground. Most of it's going to happen in the root systems. So you have to be patient. But the payoff is that their longevity and the lower maintenance requirements over the lifespan of the system will be of great benefit going forward. So I think continue to think about improving your surface water first before sending it downstream. Improve, then move is really something I like to promote if I can. I also think that when it comes to improving lake health, you need to think up and out. I've seen and been to jurisdictions where they are harvesting vegetation. I would use an example in downtown Halifax, where the Olympic team actually trains for their rowing. In downtown Halifax, they have a lake there where they're continually removing the vegetation that's growing on that lake. And I think of Chestermere Lake in Chestermere, Alberta, which is about 20 minutes east of Calgary, where they have 2 vegetation harvesters going all summer long. It's an endless process, and it's solving the problem for a short period of time in that location, but it's not really addressing where the nutrients are coming in. And so by having sort of strategies at multiple levels and in multiple locations and thinking over the long term, that probably will result in the best results for improving water quality in your location. And with that, I thank you for sticking with this, and I thank you for your time and the opportunity to present this evening.
Your mic is muted, Dennis.
I was so intrigued in listening, I forgot to turn my mic on. I was saying, I think we could listen to that all night, Lisette. That was wonderful. And we do have some questions for you. There aren't always enough funds to support all the projects that we might like to do to help improve lake health. Do you have any recommendations on how we could go about prioritizing those options and implementing them?
That's a really good question. I think if I draw upon that study that we did on Lake Winnipeg, where we inventoried the South Basin, we looked at the quality of shoreline habitat. We looked at water entering the system. We looked at water and land use beyond the shoreline. And I think by doing that sort of inventory, and doing some science to go with it, and perhaps some sampling if you've got the funds to support it, really pinpointing where your source points are helps you, I think, then identify what your strategies can be. And I don't think it has to be always complicated. It could be thinking about, different land management in certain locations, especially if it's marginal lands. It could be, as direct as revegetating your channel network before it actually reaches your water body. But I think it helps you prioritize, and then you can understand and identify where your funds are best spent and your energy.
You touched upon some of the treatment wetlands you've designed and commissioned in Manitoba. Are there certain factors that help improve the treatment capacity of these wetlands?
Yeah, there are. We could do a whole talk on just the design of treatment wetlands. There's quite a science behind them, and so when we are looking at a treatment capacity, because these jurisdictions want to make sure that they meet their regulatory targets for release, we look very closely at the level of phosphorus that's going to be coming into the system. You can run calculations on what you can expect a cattail plant to actually uptake and sequester in a given season based on the flow time through the system. And so we look at sort of incoming nutrients, the length the water's held within the system, and based on that, we look at the coverage that we need in order to hit the targets that we need to hit for regulatory release.
Can you talk a little bit about some of the lengths of time required, like the residency that's required relative to the content or constituent of phosphorus that's in the water coming in?
Yeah, it's so most treatment wetland systems are designed to have a 14 to 21 day residency time. You do need enough vegetation, however, to take those nutrients out during that period of time. So, for example, the Prairie treatment wetland feeds a slightly bigger community, has some different inputs from the St. Pierre wetland, and that treatment wetland is 17 hectares in size. The St. Pierre one is about 8 hectares in size, but we are looking at one right now, which is only about 2 acres in size. So, it depends on the size of the community, the level of nutrients going in, and the time the water is held. I would say be careful. If you think of a normal wetland, a semi-permanent wetland probably turns over its water about somewhere between every 5 to 10 years. John last week, I thought was very interesting when he was talking about the water turnover time of Lake Winnipeg versus Clear Lake, and the differences there. Same thing holds true for these treatment wetland sites. And so if you're going to run water very quickly through a treatment wetland for maybe perhaps just days and hope that you get nutrient uptake in it, you might not get the treatment performance you hope to.
You also mentioned bioswales as a treatment option for source water quality issues. And what are some of the considerations there, Lisette, in terms of establishing a bioswale?
Species selection and understanding how that site might perform. So whatever we're going into a site and looking at how to design it and how to choose the species. I often think about when you'll get water, how long you'll get that water for, and how deep that water will be. Doesn't matter whether it's a bioswale or it's a wetland. I ask myself those 3 questions because that all dictates the kind of species that you will select. So if it's a bioswale that is going to be flooded for a longer period of time, and perhaps a little bit deeper, the species you select that will sort of flourish in that kind of environment would be different than the ones that you would select for a very dry bioswale. The other challenge that we have in some of establishing some of our aquatic environments, and we've gone back to sort of just the basic science that we did in the 80s on wetland systems, is that the seeds of wetland plants are not commercially available. So for the systems we build, we collect all our seed by hand and we treat it in order to try and get it to germinate. We even do that with the cattail seeds that we collect. If you take a cattail seed and you throw it down just off the head of a plant and you throw it down, the germination rate is about 5%. If you do a little bit of treatment to it and kind of rough up the outer coating, as Mother Nature would do over a few years if it sat out on the sediments, you increase it from about 5% to about 90% germination rate. So we've gone back to some of our basic science and seed ecology that we did in the 80s and are revisiting that to kind of improve responses of certain species for certain locations, like bioswales.
Interesting. The amount of hog manure that can be applied to farmland is regulated according to phosphorus amount or content, usually. I guess both in the manure and both in the land as well. Would regulating the amount of phosphorus that can be applied to farmland through chemical fertilizer reduce fertilizer or phosphorus levels in our lakes, do you think?
It's not necessarily my expertise. I'd have to go back to my soil science days to kind of think about that. But, you know, I think one of the things that we've transitioned to over the last few decades is, you know, where we used to sort of apply chemical fertilizers with some of the other constituents in mind, like nitrogen. We've come to understand that combining it with phosphorus and managing how much phosphorus we put on the landscape is really very important as well. And so I think we've become a lot better over the last few decades in understanding that science and making sure that we're not putting down fertilizer on the landscape that's just lost then to our waterways. And I know that a lot of farmers are using management plans and stuff and have those in place to improve not only their product, but just to improve their business line in doing so.
You, in your presentation, spoke about the relationship between large inland coastal marshes that border some of our Manitoba, the larger lakes in Manitoba. And we often hear recommendations for harvesting and removing the nuisance floating vegetation. What should we consider before going down that path, do you think?
Well, it's interesting to me, like there's two thoughts. There's one is removing floating vegetation, harvesting, to kind of take those nutrients out and to get rid of them. The other is harvesting standing emergent vegetation, like in the Netley Marsh, and actually thinking about removing nutrients by taking those above ground shoots and removing them that way. When it comes to floating vegetation, the challenge is that you're not really getting rid of the source over time. And so you may be removing the nutrients at that point in time when you remove the plants, and you've got to think about, where am I taking those plants? Am I landfilling them? You need special equipment in order to do so. But the problem's going to come back, and you're going to have to do it. The nutrients want to go somewhere. And if it can't go to the soil and it can't go to wetland plants and it's not being captured before it comes to your basin, it's going to come back and you're going to have to repeat the process. In those locations where they are promoting the harvesting of natural vegetation that exists along shorelines or in marshes like Netley-Levo, I understand the purpose of it. My concern is that when you harvest natural vegetation, you put those plants at risk. And so I talked about how in the bio platform, you know, when we harvested the vegetation at a certain time of year, you can affect its ability to overwinter and succeed the next spring. Now I think about let's harvest it in something like a lake shoreline or perhaps like a Netley or a Delta Marsh. And all of a sudden you have a flooding event that you didn't expect. And lake levels rise, and now you flood over top of the harvested vegetation. What happens is you suffocate that plant from gaining air. And we studied this in the Delta Marsh. We said, if we flooded plants deep, how long would it take to kill the plant? And you can kill a cattail plant within a season. And once you've killed it, it's done. You know, you're not getting it back. And so I very much support and promote harvesting vegetation in controlled environments, like maybe managed constructed wetland systems, ditch networks and stuff where we can manage them. I'm less supportive of harvesting natural vegetation and natural habitats. I think it's risky.
That's interesting. And are there some regulatory considerations that we should consider before we would do rehabilitation work in an existing wetland or riparian area?
There are, and so and it came to mind, and Daryl, you and I were talking about this when you were talking about looking at using that wetland upslope of Sandy Lake to perhaps enhance it, move lake water through it, improve it on its way back to the lake, which is a really great strategy. One of the things is we've got pretty strict wetland policy, and I would say Manitoba does, Alberta does. They have pretty strict protection and regulatory policies in place for different classes of wetlands, from very ephemeral to very permanent habitats. So in Manitoba, for example, you're not allowed to disturb, degrade, drain a class 3, a class 4, or class 5 wetland. So semi-permanent to permanent wetland systems. And there is policy oversight on class 3s, which are seasonal wetland systems. So before you do anything, it's best just to maybe check to see if there's any kind of regulatory oversight on the landscape that you're working on. Go to your watershed district to gain help from those folks. There's some online tools as well to help you in that regard before you actually execute on something, just to be safe.
And in terms of varieties of cattails, are some varieties more effective than others when it comes to phosphorus uptake?
Thinking about the papers I've read in the past, there's basically 3 species of cattail that we have in Manitoba. Typha latifolia, broadleaf cattail, Typha augustifolia, narrowleaf cattail, Typha glauca, which is a hybrid between the two. There's some thought that augustifolia and Typha glauca are, well, introduced species, so are considered more invasive species. Typha glauca especially, you see it a lot around the Delta Marsh, you see it a lot north of Brandon in the wetland habitats. It's a chameleon. It can grow in very shallow habitats. It can grow in deep habitats because it's got features of both species. I don't think that at the end of the day, you gain a lot more mileage out of putting a different species down of cattail from one over the other. What I would say is, and one of the things that we do is when we're building our wetland systems and we collect all the cattail seed by hand and then process it, and then we have different strategies for how we seed these sites once they're ready to go, is we always use Typha latifolia. We always use broadleaf cattail because it's native to Manitoba. So the idea is not to kind of promote the spread of invasive species as part of our practice.
Are there any consequence to water quality when we're doing this in terms of stocking the lake with fish?
Well, you know, one of the things, and there was a little, I guess, conversation over the last few weeks, and it made me think about this, is I was involved in some research in northern Alberta on some lakes up there and looking at the invertebrate and aquatic invertebrate in those lakes. I'm also familiar with some of the stocking that was done on some of our more shallow prairie landscapes in Minnesota, in North Dakota, South Dakota, in the 80s. And what we found was, while, you know, they can flourish within those habitats, what sometimes happens is they actually change the trophic dynamics of the system. And so when you introduce certain species of fish, And if they are very good at feeding on certain invertebrates within the community, those invertebrates are sometimes very important in feeding on the algal species within those systems as well. So as the fish feed on these certain invertebrate species and they take them away, you no longer have that community there to actually predate on the algal communities, and you can actually flip the trophic structure of your system. And that's what we found in some of our northern lakes in Alberta, was we were flipping the trophic state and we're turning them from clear to turbid states because of some of those losses in invertebrates within them. So I think you just have to, again, sometimes improving the function of one component within the system has consequences for some of the other functions, and you just have to think it through, I think, before you execute on it.
The prairie landscape, of course, many of around our prairie lakes is largely privately owned by farmers who need to maximize their incomes. How do we reconcile their needs and to maximize income with our needs in society in general for wetland conservation to be able to improve water quality?
That's a whole evening on itself, I think. To dip my toe into the water on that one, but I think it's been long accepted by a number of folks that would like to see us move ahead when it comes to maybe improving some of our practices on the landscape, that there's a benefit for all of society. And if people have been around long enough, one of the reasons Native Plant Solutions actually started in the 90s, early 90s, was we thought that we would have a program here in Canada similar to the United States called the Conservation Reserve Program, where the federal government was actually working with landowners to help take marginal lands out of production and return them to more of a native grass state, and to provide resources and support in order to do so. And so I think, we can't put this on the back of one component of our society and expect them to provide actions that benefit the rest of us. And, I quite support having programs in place that help support and finance good land practices on our landscapes.
So are cattails hands down the absolute best plants to be growing, or are there other wetland plants that can also work, albeit maybe not quite as well?
Yeah, probably cattail really is the workhorse. And a lot of people don't like cattail because it's in every ditch. But the reality is it's good at what it does. And once it establishes, it's a pretty hardy plant. You can get nutrient uptake from, and I would say anything that's on a shoreline, that's a healthy shoreline and is robust, is adding to the water quality of your system. So, whether that's a floating plant, or it's a hard stem or soft stem bulrush, or even if it's a sedge species, depending on where it positions itself on your shoreline, if its feet are in the water, it's providing a water quality benefit to your system. So I say keep it all, but when we build these treatment wetlands, and like I said, it's function over form. We build them with cattails because we know that will consistently be your workhorse for nutrient uptake. Some people will come, and I've had this, they come from Europe and they're promoting things like Phragmites and reed canary grass, which are native to some of those jurisdictions across the ocean, but are not here. And so even though they are very good at removing nutrients within water systems, they're very invasive plants. They're very detrimental to our riparian and wetland areas. And I am not for using those species for treatment in our systems.
We're reading now and again about the introduction of aeration into, I guess, both subsurface flow. Is there anything to that, in your opinion? Does it help?
So are we thinking about aeration more in a water body, or
in a subsurface, horizontal subsurface flow filter?
I haven't I haven't really heard of that being introduced. One of the things about subsurface flow wetlands is they're complicated. They're complicated designs. Again, all the science that goes into a surface wetland in terms of nutrient uptake, flow rate, residency time should all be calculated as part of your design. It can be challenging to keep the plants alive because if you think the substrate is not really a normal soil substrate, right? It's a bit more hydroponic. So to get the right species in there and get them to survive can be a bit of a challenge. Now, if you need to add something else to your system, like aeration, you've added one more thing that you've got to maintain. You've added an additional cost. So I often think, when we approach things, I think it's very important to be honest when somebody is kind of going down a road that we think is just not doable or is going to have consequences to it. We're very honest in saying, you may want to rethink this because we've seen enough folks have headaches decades after they've taken over some project, and have to manage it. So I would say try to choose as uncomplicated when it comes to green infrastructure an option as possible to get hopefully the same type of treatment.
In terms of the surface flow wetland, we often hear people talk about maintenance. What are some of the maintenance requirements to help that well filter remain effective in its removal of nutrients?
Right. So in October of 2019, we handed off the St. Pierre treatment lagoon, tertiary treatment wetland. We started the wetland. We started commissioning it in the spring of 2018. You have to do a little bit of water level management with the wastewater in order to get the plants to grow, because a wetland plant can't germinate underwater. Its seed needs to be exposed on a shoreline or in a wetland in order for it to grow. But once we had that wetland established, and what they have to do to maintain it going forward is basically open the pipes, ensure that the flow rate is correct. And so we've worked with them on making sure that the residency time is met and making sure that you don't get muskrats in your system that will start to eat out your cattails. So just paying attention to whether they're there, are there mounds being built and trapping them out. But other than that, that's it. That's all you have to do. For the next 3 decades, that will be the only management that's required. Okemic Marsh has a treatment wetland system that was built in 1992, and they have a tertiary treatment wetland system. And we've researched that. There's been no modifications to that system since it was built. We've not had to harvest vegetation, add vegetation. We've had to do some muskrat control, but it's still providing and hitting the same performance targets as it did when it was initially constructed. So 1992, 2021, we're looking at 30 years now in on that site. That's why I think that some of the communities, especially some of the smaller communities that don't have a lot of resources to maintain these landscapes or these infrastructures, if you go with something more complicated, they're looking at this as an option because the long-term inputs are quite low. Muskrats are the problem.
Yeah. I want to thank you very much, Lisette. That is awesome. I thoroughly enjoyed your presentation, and you've done a marvelous job of your response to the questions, and to thank all of those participating tonight for the questions they've provided. You've done a great job. Thank you so much.
Yeah, thanks for having me.
Yes, well, thank you. Yes, thank you very much, Lisette. That was great. Thank you, Dennis, for fielding the questions there. Good evening, everyone, and thank you again for all joining us. All the best to you and your families during this pandemic.